EDC release the energy stored within the reduced hydrogen carriers in order to synthesize ATP. Phosphorylation, as the energy to synthesis ATP is derived from the oxidation of hydrogen carrier. Protein carriers plays vital role in ETC.
Let us have a short look on protein carriers. Complex 1 is an NADH dehydrogenase complex. It is an integral protein that receives electrons in the form of hydride ions from NADH and passes them to ubiquinone. Secondly, complex 2, succinate dehydrogenase complex. It is a protein that receives electrons from succinate to yield the fumarate from Krebs cycles and FADH2. From succinate, the electrons are received by FAD, which then become FADH2. The electrons are then passed on to ubiquinone. Complex 4, cytochrome C oxidase. It is an integral protein that receives electrons from cytochrome C and transfers them to oxygen to produce water within the mitochondrial matrix. ATP synthase, an integral protein consisting several different subunits. This protein is directly responsible for the production of ATP via chemiosmotic phosphorylation. It uses the proton gradient created by carriers in ETC to drive mechanical rotor. Energy from the rotor used to phosphorylate ADP to ATP.
Phosphorylation occurs over a number of distinct steps. Proton pumps create an electrochemical gradient, which is called proton motif force. Next, ATP synthase uses the subsequent diffusion of protons, which is called chemiosmosis, to synthesize ATP. Also, oxygen accepts electrons and protons to form water molecules. To the steps that involve in electron transport chain. At complex 1, NADH will be attached, which form in glycolysis and Krebs cycle, where at complex 2, molecule FADH2 that produce in Krebs cycle will be attached. For complex 1, the molecule NADH will be converted to NAD+. In this reaction, hydrogen ion will form as well as electron. So, for complex 2, FADH2 will be converted to FAD and hydrogen ion and electron will be formed as well. Then, the electron will move along the electron transport chain where it will loses the energy. So, hydrogen ion will be pumped from matrix to intermembrane at complex 1 and 2. So, this is the electron transport chain where this intermembrane part is the accumulation of hydrogen ions within the intermembrane space creates an electrochemical gradient, which is a proton motif force.
The proton motif force will cause the hydrogen ion to move down their electrochemical gradient diffuse back into the matrix. This diffusion of proton called chemiosmosis, which is facilitated by ATP synthase, As the hydrogen ion moves through ATP synthase, they trigger the molecular rotation of the enzyme synthesis ATP, where the ADP changes to ATP.
In order for the electron transport chain to continue functioning, the de-energized electrons must be removed. Oxygen acts as the final electron acceptor, removing the de-energized electrons to prevent the chain from becoming blocked. Oxygen also binds with free protons in the matrix to form water molecule. Removing matrix protons maintains the hydrogen gradient.
NADH pumps out 10 hydrogen ion and 1 FADH pumps out 6 hydrogen ion. So, the final product of ETC is 32 ATPs and water molecule. That's all from us. Thank you for